Hello everyone, this is Miss Riot, and today we're going to have a look at some quadratic sequences. So I've been told that you did particularly well on the linear sequences assessment, so we're going to have a look at the harder versions and quadratic ones. So we're going to start by looking at n squared as a sequence. So I'm hoping you can figure out that just means it's your square numbers. So n squared is 1, 4, 9, 16, 25, 36, 49, so on and so on. Might be worth jotting that down somewhere just to make it a little bit easier further down the line rather than having to think of it every time. So the square numbers we just write as n squared. So let's have a look at this top question. How do you think you'd write the nth term of 2, 5, 10, 17? Well, if we compare it, and in fact I'm going to copy and paste it. If we compare it to the n squared sequence, which is just underneath, you can see that this sequence, in fact, is the square numbers, but plus 1. So I've got 2, 5, 10, 17. So I would just write that as n squared plus 1. So if I move this here, why don't you have a quick go? Can't really line it up apparently. A quick go at trying to figure out what this bottom one is going to be. Okay, hopefully you managed to spot that is going to be n squared plus 6 because it's 6 above the square numbers each time. Okay, let's have a look at these. So again, I've got my square numbers. And again, looking at the difference between them, hopefully you can see that this time they're double. So we would write that as 2n squared. Okay, and now you have a quick go. Remove that there. Again, they don't line up properly, unfortunately. But what do you think the nth term of that sequence is going to be? Okay, hopefully you spotted that it's 5n squared. It's 5 times the square numbers. Okay, let's have a look at this one. You might be able to see that this one, remove the filling now, this one is 3 times the square number, so it's 3n squared. But that's going to help us with this bottom one, because we can't compare it straight away to the square numbers, because you'll notice, so that one either add 4 or times by 5, but that doesn't apply to the second one. It's not the same rule. But I can, that's going to be both of them, I can compare this sequence, which we know the nth term of, because we know that's 3n squared. And look, hopefully it becomes a bit clearer. It's 3n squared. I'm just adding 2 each time. So this one has an nth term of 3n squared add 2. Okay, so here's 5 sequences. I want you to pause the video and have a go at these. And they're all going to be either just something n squared or something n squared add or minus something. Okay, so I'm going to reveal the answers. These are the answers. If you could mark your work. Well done if you got 3 or more of those correct. And now we're going to have a look at a slightly more trickier one. So this one, there's a bit more of a method, and I'm going to write down steps for you to follow. And on a worksheet that I'll provide, there's sort of more steps that you can follow as well. This is going to be of the form, so something n squared plus something n plus something at the end. So slightly trickier. So we're always going to start by finding the difference. So my difference there is 9. This is not going to go well for handwriting at all. We've got 13. There we've got 17. And there we've got 21. Now with a linear sequence, these would all be the same. Because it's a quadratic sequence, it's not going to be. In fact, this second difference is what's going to be the same, which is not 2. Helps when I can add. It's going to be 4. 4 each time. And we know it's quadratic if the second difference is the same. So if you want to find this, if you want to write down a step 1, you want to find the second difference. Okay, or you might call it the difference of the difference, same thing. Now, step 2, we halve it. And that's going to tell us the coefficient, or the number in front of n squared. So we're going to be looking at here 2n squared. And I'm going to show you why we halve it in a minute, but you always need to halve it. So halve it gives you coefficient, that's the number in front of n squared. So let's write this out. And again, if you did the exercises earlier, you might sort of have it to hand, easier to compare. So we're going to have 2, 8. So remember, this is just your square numbers doubled. 18, 32. I'll stop there. Oh, that was meant to be a dog. And this is what we're going to compare to our sequence. So instead of just comparing it to the square numbers, we're going to compare it to 2n squared. But you'll find, again, there won't be a pattern in the sense they won't always be the same. And we're going to see what we do with that. So the correct way around to do it would be to do your sequence. Right, step 3. Brilliant. Sequence minus 2n squared. Let's do it that way around. So I'm going to do 4 minus 2, which is 2. 13 minus 8 is 5. 26 minus 18 is 8. 43 minus 32 is 11. And that's as far as I've got. And that is enough. And the last thing, so although it isn't the same, you might now have realised that that is a sequence within itself. So we're going to find the nth term of this sequence, which hopefully you can sort of do in your head now. So we're going to have 3n minus 1. So our final answer is going to be 2n squared plus 3n minus 2. Good, got it correct. So you might want to play that video again, or I will show you as well where you can find other videos with other examples. And hopefully that gives you a step-by-step guide how to solve them. Really quickly, you want to go, why do we halve the second difference? So if I do any sequence, if I plug in the first term where n is 1, my first term would be a plus b plus c. If I plug in n equals 2, well, I'd get 4a plus 2b plus c. If I do n equals 3, I get 9a plus 3b plus c. And if I plug n is 4 in, I get 16a plus 4b plus c. And if I find those differences, so the c disappears, I've got 3a plus b, 5a plus b, 7a plus b, and find those differences, it's always 2a. So even the most general thing, it's always 2a. So a, the coefficient of n squared, when we find that second difference, it's always double it. So that's why we need to halve it. You do not need to learn this proof at all, but it's just for your interest. Okay, so there's going to be a worksheet attached that looks like this, that breaks it down nice and easily for you. It's got an example like this at the top and another 4 questions. I've also got 8 questions here just for you to have a go at. And then I've got an extension, that should say find the nth term, which is some cubic sequences if you are feeling a challenge. So I'd like to pause the video here, have a go at some questions, so sort of easiest on the sheet next and then hardest here. And I'll pop the answers to the bottom 2 exercises in a minute. Okay, so the answers are here. Please mark your work. Okay then, so that was quadratic sequences. Please feel free to get in touch with me if you have any questions. Other than that, I hope you have a good day and keep practicing.